Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about this problem. So let's get started. Let's see this problem. We are given an array of elements and our task is to find the index of largest element in an array. To understand this problem really well, let's see few examples. So if the input is this array, there are 5 elements in this array, 1, 2, 3, 4, 5. And these are the index of this array. And as you can see that the largest element present at the index 4. So the output of this array is 4. Moving to next example. In this example, the input array is given as 5, 4, 3, 2, 1. And you can see that the largest index is present at the index 0. So that's why the output of this input is 0. In next example, we have only one element in an array. So the output of this input is 0. It means the first element and the only element is the largest element in the array. And it is present at the index 0. So now you have clear understanding of this problem. So let's pause the video and try to write an algorithm to solve this problem. So before we talk about efficient approach, let's talk about the brute force approach to solve this problem. The idea of brute force approach is pretty simple. Let's say we have this array and there are 5 elements in this array, 1, 2, 3, 4, 5. What we do? We simply pick one number at a time and then we search the entire array to find the number that is larger than this number. If we found at least one number that is larger than this number, then we simply stop and then we pick the second number. And if we found that there are no such number that is larger than this number, then we simply stop and return the index of the number we are checking for. So this is the simple idea. So now let's see the implementation of this brute force approach. So here we have a function and this function is taking array as input. In the first statement of this function, we are simply getting the length of the array. As arrays are classes in Java, so we simply using the property of this class, that is length, to get the number of elements present in the array, so that it helps us to run a loop for all the elements in the array. After this statement, we are running a loop from 0 to less than n for all the elements present in the array. And then I am using one variable exist and initialize this variable to false. And then I am again running a loop from j equal to 0 till less than equal to n. And inside this loop, I am checking if array of j is greater than equal to array of I. It means in the first loop, we are picking one number at a time. And in the inner loop, we are traversing all the elements of the array. And we are trying to find that if there exists any number that is greater than this selected number or the chosen number. If we found that there is a number that is greater than that number, then we simply set the value of exist variable to true. It means we found a number that is greater than that number, and then we simply break the inner loop. And after inner loop, we check if we found a number or not. It means if number exists or not. If not exist, it means the number we are looking for is the largest number in the array. So we are simply returning the index of the number that we are checking. Okay, and after outer loop, we are simply returning -1. So although we are never going to reach this return statement, I am just using return -1 just to prevent the compilation error. Okay, because the return type of this function is integer. So anyhow, we have to return some value to prevent the compilation error. So now let's quickly do the dry run of this problem to see how it works. So let's say we have an array and there are 3 elements in this array, 10, 20 and 30, and these are the indexes of all the elements. When we run this program, our loop begins, and in first iteration the value of I is 0. The element present at 0th index is 10. The inner loop is going to check all the elements in the array. It's going to check for 10, it's going to check for 20. When it checks for 20, it found that 20 is greater than 10, right? So it simply set the variable exist to true. It means there exists a number that is greater than 10. So it breaks the loop and then we continue to next iteration. In next iteration, the value of I becomes 1 and the element present at index 1 is 20. Okay, then inner loop begins and it starts from 0th index. It checks for 10, then 20, then 30. Now at this moment it found that 30 is greater than 20. It means there exists a number that is greater than 20. So it simply breaks the loop and set variable exists to true. And we check if in here we are checking not exist, but the value of exist is already true, so we never go into this if statement. In next iteration the value of I becomes 2 and the element present at index 2 is 30. The inner loop again starts checking all the elements one by one. It checks for 10, 20 and 30. This time it never found any element that is greater than 30. So the value of exist remains false. So this time the condition of if statements becomes true. Okay, because we are using not here. Not exist means if we have false here, then we enter into this if statement. At this point we simply enter into this if statement and we are returning index of 30 and that is 2 because we are checking for index 2 in this iteration. Okay, so far so clear. So 2 is the index of the largest element in this array and that is true. Okay, I hope you got it. Now talking about the time complexity of this function. So to find out time complexity we have to first find out that how many times loop is running. So let's say in best case we get this array 3 to 1. Okay, so our outer loop runs theta of 1 time and the inner loop runs theta of n times. And in the first iteration itself we get to know that this is the largest number in the array. But in worst case, if we get array like this 1, 2, 3, then the outer loop runs theta of n times and the inner loop runs theta of n times. Okay, and we generally care about the worst case scenarios. Okay, so the overall time complexity of this function is going to be n cross n. It is a product of time taken by both the loops. So it's going to be theta of n square means, and this time complexity belongs to the class of quadratic order of growth. Okay, now talking about the space complexity, as we are not using any extra or auxiliary space here, so the space complexity comes out to be theta of 1 and that is a constant space. It means we are taking theta of n squared time and theta of 1 constant space to solve this problem. Okay, so far so clear. But the question is, can we do it better? Do we have any approach to solve this problem in theta of n time complexity? Think about another approach to solve this problem in less time complexity. So I hope you got some idea to solve this problem in less time complexity. So now let's talk about the idea for efficient approach to solve this problem. Let's say we have given an array with only one element. So if array contains only one element, then we simply say that this is the largest element because the array has only one element, right? So the output of this input is 0. Now, if I add one more element to this array, and previously we already found that the first element is the largest element, and now if I add one more element to this array, then there are three possible cases that could happen. Number 1, either second number is less than first number, or second number is equal to first number, or second number is greater than first number. So if second number is less than or equal to first number, then we do not need to do anything. In this case, first number remains the largest number, right? But what happens when second number is greater than first number? It means we have got one number that is largest than first number, right? So we simply say that this is the largest number so far. So we set the second number as largest number, simple. Now, till now, we have two elements. And in two elements, we know that the second element is the largest element. So till second element, we got the largest element. Now what if I add one more number to it? Then what will happen? Again, there are three possible cases that could happen. Okay, either third element is less than second number, or equal to second number, or greater than second number. So we just have to repeat the same process, right? If third number is greater than second number, it means we have got one more number that is the greatest among all the number, correct? So we just have to follow this process for all the elements. So we first start by assuming that the 0th element is the largest element. In the first statement, we are simply storing the length of the array in variable n by using the length property of the array class. Okay, and then we are assuming that the first element at index 0 is the largest element. So that's why I am storing 0 in index variable. And then we are running a loop from 1 to less than equal to n. Okay, and in each iteration we are checking if the current element is greater than element present at this index. And if we found that the element is greater than this index, then we simply update the value of index variable. And in the last, we are returning value of index. So let's quickly dry run this code and see how it works. So in case we have only one element in array, we are assuming that the first element is the greatest and the largest element. So that is why we are storing index of the first element. So in case of one element, this loop starts from 1 and we does not have index 1 in this array. So this loop is never going to run. So this function simply returns 0 in case of one element. What happens if we have elements like 1, 2, 3? So we assume that the element at the 0th position is the largest element and this is the index of the largest number. So our loop begins. In first iteration, the value of 1 is 1, and at position 1, at index 1, we have number 2. We compare that if 2 is greater than 1 or not. 2 is greater, so that's why we update the value of index to 1. Means till now we found the largest number at index 1. And we move to next iteration. In next iteration, the value of I becomes 2. The element present at index 2 is 3. And this time we check if 3 is greater than element present at index 1 or not. It means 2. Means 3 is greater than 2. So we simply update the value of index variable to index 2. It means till now the largest element that exists in this array, it is present at the index 2. And in next iteration our I becomes 3 and 3 is not less than 3. So the loop breaks and we come out of the loop. And in the last it going to return number 2. And that is the index of the largest element present in the array. So far so clear. Now talking about the time complexity of this function. So how many times the loop is going to run? So in this case, either we get this array or this array. In both the cases, loop is going to run n times only. So the overall time complexity of this function is going to be theta of n. And space complexity remains the same as we are not using any auxiliary space. So the space complexity is going to be theta of 1, that is a constant space. So it means this solution is taking theta of n time and the theta of 1 space to solve this problem. Great. Before we end this video, let's have a quick recap of what we have learned so far. So we are given an array of elements and our task is to find index of largest element in this array. We saw the brute force approach to solve this problem and the time complexity came out to be theta of n square. After brute force approach, we saw the efficient approach to solve this problem and the time complexity came out to be theta of n, and that is much better than n square time complexity. So this is it for this video. Thanks for watching and see you in the next video.